All right, here we go. Calculus 101. The start. This is the biggest problem that we've been doing since basically Algebra 1. I've taught this to you, okay? And it is the power rule, right? And the power rule is really simple, okay? It looks complicated. d of dx of x to the n is equal to n times x to the power of n minus 1 dx.
Does d stand for derivative?
The derivative of the variable x. Alright? And so, what you're doing with the power rule is you're taking the power and you're multiplying the coefficient. Right? And then you're taking 1 away from that power. Okay? And so, like last year when we did these, they were really easy. Right? They were, take the power, right? What's 2 times negative 2?
Negative 4.
Negative 4. What's 1 from 2? 1. Okay? So f prime of t is equal to negative 4t. Now what's 1 times 3?
3.
3. And then what's 1 away from 1? 0. And so what happens here is you would actually have t to the 0 here, right? Which is just 1. Right? Any number or raised to 0 power is 1. Right? And so that leads us to this equation right here. This is really t to the 0, right? This is 1. So you have 0, 1, 2, okay? And so what is 0 times 6? 0. And what you get here is minus 0, right? And what's 0 minus 1? Negative 1. Times t to the negative 1. Now, this is really just 1. And what's 0 times anything? 0, right? So these go away. And that's why you're only left with f prime of t is equal to negative 4t plus 3. And that is your derivative. Okay? And we did that. We did that derivative. Do you remember when we were trying to find the maximum and the minimum value? So where this hump was, so the axis of symmetry, remember that? So if we set this equal to 0 and solve, we would find the axis of symmetry. And if we plugged it in, we would find the vertex to the axis of the symmetry. And we would see that this is a negative, right, quadratic, right? And where its axis of symmetry is going to be at 3 over 4, right, or 3/4.
Wait, what?
If we were to graph this, we would set this equal to 0 and all that. No, we're not doing any of that right now. What we're doing right now is just finding the derivative. Okay? But this is where we started last year. So let's do this one really quick. This was pretty easy, right? So what's 2 times 1?
2.
2? And 1 from 2?
1.
1. And what's 3 times 4?
12.
12? And 1 from 3?
2.
2. Now we would reorder that, right? And we would say this is 12x squared plus 2x.
You don't break it down at all?
No, we don't factor it. We just find the derivative. We're going to have uses for these derivatives in the future. But that's all we're doing, is finding the derivative. Now I chose these because they're easy. We've done these, right? Now when we start to do these other ones, right? When we come to this one, now it's kind of funky, but it should make sense now, right? So remember, there's an x to the 0 here, right? With the 8. And then what is 0 times 8?
0.
So y prime is equal to 0. So y prime and g prime, g of x prime, sorry, and f of t prime, they're all the same thing. They're all the derivative. It's all ways of saying the derivative. Okay?
So, that little, I don't know what to call it, like that little apostrophe thing, that's derivative?
Yeah.
Or prime?
Yeah. That's the first derivative. And if you do two derivatives, then you would just do it again.
But with the quotation mark?
Yeah, you'd have two quotation marks on the second derivative. Okay? So what's the derivative of this guy?
Y prime equals 6x, like 6x to the 5th power?
Yep.
Figure out the prime.
Sorry. Thank you. Pretty easy, right? So it's just 6 times 1, which is 6. And then 1 from 6 is 5. That's it. Simple. That's the power rule, right? Now, Charlie, let's have fun with it. The next one. What do we do with this guy? How do we set this guy up? Right? So now we got to rewrite it. Y equals x to the negative 7, right? Because if it's in the bottom, it's really negative. So we're going to pop that up to the top. And then we're going to start doing the power rule. So what is? Huh?
That doesn't make sense.
Well, remember, all we do is bring this up and make it negative. That's what a negative exponent is.
What about the x?
That's bringing the x up.
Wouldn't that make it a negative 2 then?
Huh?
Wouldn't that make the x a negative 2?
No. It's just the power. So in other words, 1/2 is equal to 2 to the negative 1. All we did was bring that power of a 1 up to the top, right? We brought it up to the top and made it to the negative 1. It wouldn't make it a negative 2. It's still 1/2.
And if it was 2 over x to the 7th power, it'd just be 2x minus 2 to the negative?
Yes. 2 over x to the 7th power would be 2x to the negative 7. Right? And then we would multiply it.
We solve.
Right? So what's negative 7 times
Negative 7.
times 1?
Negative 7.
Yeah. So we get y prime is equal to negative 7. And then what is negative 7 minus 1? Negative 8. And then if we rewrite this, how do we rewrite it? Y prime is equal to negative 7 over x to the 8. And those are both ways of saying the same thing. Okay? Woo! You want to do the easy ones and then come back to the fun one? This one's pretty easy. Well, what's 1 times 1?
1.
Yeah. So f prime of x is actually just 1. Done.
What about the plus?
Well, it's plus x to the 0, right? So what's 0 times 1? 0 plus what? So all numbers just fade away. Does that make sense? Sutton. All right. Let's do this one real quick. Sutton, help me with this one. All right. So, s prime of t. I'm just going to take the 2 times the 1. What's 2 times the 1?
2.
Yeah. So that equals 2t to the what power? So then you're going to take 1 away from the 2.
1.
Yeah, 1 power. Now, you're going to take this 1 times the negative 2.
Negative
And then 1 away from 1 leaves 0, right?
Yeah.
And so we're done. Because t to the 0 is just cancel that out, right?
Yeah.
Done. And that's an easy one, right? That's the one we were doing last year, right?
Yeah.
Now let's do the fun one. Let's do this guy. This guy's funky, all right? So remember, let's change it back to what it is. This is really f of x is equal to x to the 1/5, right? Because radicals are really fractional exponents, right? And now when we take the function f prime of x, right? Then what is 1/5 times 1? 1/5. So this is 1/5 x, right? And then what's 1/5 minus 1?
Negative 1/5.
Negative 4/5, right? Because you had a 1, you're subtracting a 1, so you're subtracting 5 over 5/5, right? From 1/5, so the 1 is canceling out the, taking 1 from 5 and leaving 4.
That makes sense.
Okay? Now, is it a negative? Right? So negative brings it what?
Down.
Brings it to the bottom, right? So that means f prime of x is really equal to 1 over 5 times x to the 4/5, right? And then what is 4/5? Which one goes in the root? Where's the root in a plant? The bottom, right? So this bottom is the root. And so we're going to have f prime of x is actually equal to 1 over 5 times the 5th root. So we're going to take that 5 right there, put it right there. Okay? The 5th root of x to the 4th. So this 5, right, is becoming that 5. Does that make sense? So that's the fun part. That's where it gets interesting. That all kind of got really close together, a little bit too close for my comfort. But if you rewind the tape, go back, follow it through. I like the way that we started it with these more. I think this was more easier than just starting this way when I noticed that. So that's why I went that direction with it. Questions before I turn the tape off? So this would be the 5th root. Yep. Yeah, so just remember, it's a good question, that this is a 5th root of x to the 4th, right? So 5 times the 5th root of x to the 4th. And that's all over, or all under 1, right?
On that same problem, can you explain how you got 4/5?
4/5. So again, let me erase part of this, right? To get 4/5, right? We have 1/5 minus 5/5, right? And so what's happening here is we really have 1 minus 5 over 5. Okay? So let me do that again.
Can you leave all the steps up there?
So you go here, then the next step would be 1 minus 5 over 5, right? And then 1 minus 5 is negative 4/5. Good questions.
Is that a minus or multiplication?
Minus. Minus. So those are fun.
Okay.